In this video, we are going to discuss about various encoding scheme. So basically, there are four classifications. One is analog to analog. The example of analog to analog is AM, FM and PM, that is amplitude modulation, frequency modulation and phase modulation. As you can see, the analog signals mixed with the high frequency carrier signal to produce a different type of signal. So such type of method is considered as a coding or encoding technique. So this is an analog to analog encoding technique in which we are converting any analog signal to its corresponding different analog signal. Then second is analog to digital. The example for this is pulse amplitude modulation, pulse width modulation and pulse position modulation. As you know that the information is in the form of analog and we can convert those information into its corresponding samples. In PAM we change the amplitude, in PWM we change the width and in PPM we change the position of the pulse. So basically we are converting the analog information into its corresponding digital signal. So this type of conversion or this type of encoding is known as analog to digital encoding. Third is digital to analog. That means our information is in the form of digital and we are converting this digital information into its corresponding analog output. So such type of encoding example is ASK, FSK and PSK, that is amplitude shift keying, frequency shift keying and phase shift keying, in which we have seen that the information in the form of binary data and we combine this binary data with a high frequency carrier signal to transmit this signal. So such techniques are known as digital to analog encoding techniques. And the final technique is digital to digital. The examples are various digital encoding which are as follows. So we will see how the digital to digital conversion is processed and how these techniques are differ with one another. So the very first is unipolar encoding technique. Uni means one. That means it has one polarity. It is also called on-off technique. On-off is represented by for bit 1 it is on and for bit 0 it is off. You can see the diagram. This is for bit 1 it is having a positive polarity and for bit 0 it is having zero polarity. Again for bit 1 it is having positive polarity and for 0 it is having zero polarity. So this type of diagram is represented as NRZ. NRZ stands for non-return to zero. Non-return to zero that means it is not returning to zero. Same unipolar can be represented with RZ. This RZ is return to zero. That means it is returning to zero. Every bit is returning to zero at its mid position. As you can see, the width for 1 is this much. It is shown by the dotted lines, but it is coming down to zero level at the midpoint. So that is why it is known as return to zero. This is non-return to zero. It is not returning. It is occupying the whole bandwidth. It is occupying only the half. So this is 1, then this is 0, no polarity, 1, 1, 0, 0, no polarity. So it is return to zero. Similarly, for all the techniques, I have shown NRZ and RZ both. So the second type of technique is a polar technique. In polar technique, we have two polarities. One is positive polarity, another is negative polarity. That means bit 1 is represented by positive polarity and bit 0 is represented by negative polarity. As you can see in this diagram, 1 is represented by plus V, 0 is represented by minus V. Again plus V, minus V. This is non-return to zero. Same way return to zero, we can see that it is coming to zero position at midpoint. 1 returning to 0, 0 again returning to 0, 1 returning to 0 and so on. So this way both 1 and 0 are returning to 0 at the midpoint. So this is RZ polar and this is NRZ polar. Third is a bipolar. Bipolar means it is also having two polarity, but both polarities are for bit 1 and for 0 it is having 0. It is also called AMI, which is alternate mark inversion. Now what is mark? Mark means 1 and space means 0. So in standard form mark is always represented 1 and space means 0. So alternate mark inversion means alternatively mark will invert. That means alternatively bit 1 will be represented by some polarity, either positive or negative, and space, that is bit 0, is represented by 0. So you can see that for bit 1, first bit 1 is represented by plus volt, and then 0 is represented by 0, then next one is represented by minus V, and then again next one is represented by plus V. So this way all ones are represented by some polarity. It is either positive or negative alternatively. So that is why bipolar is also called AMI. Same thing can be represented in RZ form. 1, it is coming to half. This one is also coming to 0. This one is also coming to 0 at the half width or half bandwidth. So this is bipolar or AMI. Next is Manchester encoding. So in Manchester encoding, 1 is represented by downward arrow, 0 is represented by upward arrow. This is what the representation of 1 and 0 standard. This is Manchester, but Manchester has two types. One is plain Manchester, another is differential Manchester. How it is differ, you can understand with the help of this diagram. So as 1 is represented by downward arrow, this is the downward arrow, bit 1, then this is bit 0, upward arrow, again bit 1, downward arrow, bit 1, downward arrow, bit 0, upward, bit 0, upward. So this way 1 and 0 we are representing by downward and upward arrows. Differential Manchester, how it is differ from differential Manchester? In this, always bit 0 will be represented by its previous representation, whether it is upward or downward. So suppose this is bit 1 which is represented by downward arrow, then next comes the bit 0. So it will be represented by its previous representation which is downward. So 1 is, that means at 0 it is not changing its conversion. It will remain the same as previous denotation. So after 0 it will be 1. So for 0 to 1 it is changing. Then from again 1 to 1 it will again change. So it is again changed. Then you can see that this is downward, and after this we have two zeros. So for both the 0, this is not changing, it is keeping the previous representation or notation as it is. So 0 0, and this is 1, but both these zeros are same as the previous one. So always 1 will change its notation and 0 will not change, and rather it will follow the previous notation. So this is all various types of encoding scheme. I hope you understand the various concepts and various representation of digital encoding. If you have any doubt, you can write it in the comment section.